Let's start with a few exercises. Consider the following methods. What would happen if I did, for example, x of false? Well then, which x would I go to? Well, false is a boolean, so therefore I would go to boolean right here and print boolean. What about x of 5.7? Well, 5.7 is a double. It doesn't match any of like boolean, string, or int. So therefore it's going to print double. What about x of QWERTY? Well, that's going to be string because that doesn't match int, double, or boolean. It only matches string. Now what about x of 5? Now 5 doesn't match boolean or string, but it matches both double and int. So which one would it be? It turns out in this case it would be int because 5 is closer to an int than a double. Or int is in general more specific than a double. So in general, if multiple different methods with the same name match, then we go with the most specific one. So in this case, int is more specific than double. However, in the x of 5.7 case, that logic does not apply because int actually doesn't match 5.7. Here's another one. Let's just say we have that method. Now, what would happen if I did y of 2.9? What would happen? Well, it would actually not work because 2.9 cannot be converted to int. Int is not precise enough. We can't go from 2.9 to int. That we would have to like make it an int or just directly pass into or something like that. Because directly doing this is not allowed. Now, what if I change this thing instead to double? So let's just say we had that method right here. Now, what would happen if I did y of 8? What would be the output? Well, actually, it would be 64 because int can be converted to double. So double cannot be converted to int, but int can be converted to double. Directly, it's like implicitly converted to int, but int can be implicitly converted to double. You must explicitly convert double to int if you want to do that. Now, what would happen if we have both of these methods here, and then we call, for example, say y of, say 5.0, then which method would it call? So first, 5.0 obviously matches double, but doesn't match int. Well, it turns out it actually doesn't match int. Basically, when I call it with 5.0, it'll call the one with double, and in this case, print 5 times 5, which is 25.0 in this case. Now, why doesn't 5.0 get converted to int? Because, well, I explicitly put it in double format, like so. Basically, in general, a number put in doubled format, even if it could be an int, is not considered an int. So for example, if I don't even have that double method here, now this call won't even work because I only have an int, but 5.0 is not really an int until I convert it to an int. So therefore, this doesn't work. Because in general, you can always convert to less specific and more general forms or types, but you cannot convert to more specific or less general types. So here's another example. Public static void z int a print, let's just say option 1 public static void z int long a system.out.println option 2, and then public static void z short a system.out.println option 3. And for those of you that don't remember, short is just basically even smaller version of int, and long is like larger version of int. Basically you can get numbers that are larger. Meanwhile short only goes up to like 32,000 something. So what would happen if I call something like z of 9, for example? Would it call this method option 1, option 2, or option 3? Well, it turns out it'll be option 1. Now, why is that? Well, here's the logic. First of all, what does 9 match? Well, 9 matches with int very fine. It matches with long very fine. However, actually it doesn't match with short because, well, 9 is an int value. So, and short is more specific. It's less general. So therefore, int cannot be converted to short. So therefore, option 3 is eliminated. So now between option 1 and option 2, int is more specific. There's less values. So therefore, we go with option 1. And just to show, if we comment out both options 1 and 2, then it's not even going to work because we can't convert from int to short. Now, you may ask, how would you even call a method that takes in a short parameter? Well, first of all, a method, generally it's a pretty bad practice to have short parameter. But anyway, if you have that, you have to make it a short like that. Or you can pass in a short variable like that, because then Java will know that it's a short. Here's another example. So suppose we have these 4 methods, and if you don't remember, byte is basically an even shorter int. So basically short goes up to 32,767, but byte goes up to 127. So byte is even more specific, but even less general. Then, first of all, let's just call it on a bunch of times. So what would this piece of code do? So first of all, a of 5, well, we already went over. It matches int, it matches long. It doesn't match short and byte because int cannot be implicitly converted to short and byte that way. So therefore, a of 5 is going to be 1. So this thing is going to return 1. What about a of 5L? Well, actually, 5L, if you don't remember, is basically the long format of a number. That's how you make a number a long. So basically, that would return 2. And now, what about, so we have these 4 variables. What about a of I? Well, it's an int, so yeah, it's going to be this. What about L? Well, it's a long variable, so it's going to be the long, because none of the others work. What about a of s? Well, it's a short variable, so byte doesn't work, and int and long are not specific enough. And similarly, the byte one returns 4. So what would the output be overall? If you said 1, 2, 1, 2, 3, 4, then you're wrong. Actually, it doesn't do anything. Because, well, all we did was call the method, and the method just returns something. It doesn't print anything. So actually, we would need to print all of these like this. And now it's going to be 1, 2, 1, 2, 3, 4, as shown below. Now, here's where things can get interesting. What if we have 2 parameters? So let's first start with this example. What would b of 5, 7 be? Well, that would just be 1 because int is more specific than double, and it just happens to match int. What about this? B of 5.3, 7.7? Well, that would be 2 because, well, it just simply doesn't match this one. Now, what about b of 5.0 and 7? What would that be? Well, actually, that would be 2. Well, why is it not 1? That's because I don't care that int is more specific if it doesn't match with this. So 7 matches, but 5.0 does not match with int. So therefore, it'll be the double option. Now let's do another more interesting example. Public static void C, this time int I double j, and then double I int j, and then I print 2 here. So what would happen if I did C of 5, 7.5? Well, that would be option 1 because, well, simply option 2 just doesn't fit the 7.5. 7.5 is not an int. What about C of 5.07? Well, that would just simply be the second one because 5.0 is a double, 7 is an int, but 5.0 is not an int. Now, what about C of 5.3 and 7.5, like that? Then it wouldn't work because it matches neither of them. Because double cannot be converted to int in here, 5.3 is not an int in the first candidate, and 7.5 is not an int in the second candidate. So that would not be allowed. What's interesting is what if we do C of 5, 7, like that? It turns out it's actually also not allowed. Now, why is that? Well, let's see. 5 matches int, 7 matches double. Second method, 5 matches double, 7 matches int. So then, therefore, both of them match. So now let's determine which of these is more specific. And since this one's just int double and that one's double int, they're the same types except in different order. There's no way to determine which one's more specific, so Java doesn't know which one I'm calling, the first one or the second one. So Java just doesn't allow me to do that. In general, if neither method is more specific than the other, then it won't allow you. Java won't allow you to call it that way. Like these two methods can still coexist, but when called with inputs that make neither of them more specific, but both of them match, then we have problems. What about this example? What would happen if I call D of 5, 7.0, 7.0? It would be 1, as expected, because it matches this, but 7.0 is not an int. What about D of 5, 7.5, 4.7? that would simply also be the first one. Now what about d of, say, 5, 9, 3.6? Then which one would it be? Well, actually, let's take a look at this. 5 matches int, 9 matches double, and 3.6 matches double. And over here, 5 matches double, 9 matches int, but 3.6 does not match int, so therefore it's going to be the first one. What about d of 5.4, 4.7, 8? That would not work because in the first case, 5.4 does not match int, and in the second case, 4.7 does not match int. So that's not allowed. Now, what's interesting is what happens if I do something like D018, for example. Actually, that would not be allowed because 0 matches int, 1 matches double, 8 matches double. First one is verified. 0 matches double, 1 matches int, 8 matches int. So method 2 is verified. Now, both of them are verified. Which one is more specific? Well, in here, int is more specific than double, but then in here, double is less specific than int. So therefore, neither of these methods are more specific than the other. It doesn't matter that there's 2 specific points for here. We don't score it based on that. A method must be strictly more specific than the other method. So this calling would not work. Now let's switch our focus to something that's pretty important. So let's start with a simple example to illustrate our point. Just say we have if true int I equals 7. The question is, well, there's 2 questions. One is, are we allowed to do system.out.println I inside the if statement? That's obviously true. The second question is, are we allowed to do it before int I equals 7? That's obviously absurd because we didn't define it yet. The third question is, are we allowed to print it outside of the if statement? Well, the answer is actually no. Basically, we have that the variable I is declared inside of the if statement, which means that it runs out of scope once it reaches the end of the if statement. So therefore, we cannot access it outside of the if statement. Now, another question. Int A equals 5 outside of the if statement and before it. And now, the question is, are we allowed to do system.out.println A? Well, the answer is obviously yes, because otherwise, well, and Java would fall apart if you're not allowed to do this. There's so many example problems where we did this. So yes, we are allowed to do that. So in general, if a variable is declared inside of a block, then it runs out of scope, or in other words, disappears when the block ends. This is different than initializing. So if we do something like a equals 7, then we do system.out.println A. A is still going to be 7 because, well, A did not run out of scope. So even though we're doing stuff inside the block, changes still exist and apply outside of the block. It's only variable declarations, so this rule doesn't apply to changes. So basically, the implications of this rule are the following. If we have a variable outside, so before a block, then immediately before a block, then the block can access the variable. However, if we have a variable inside the block, So if we declare a variable inside the block, then the variable cannot be seen anywhere outside the block. So let's do some examples with this. Let's just have these useless blocks, which, by the way, don't ever do this except in illustrating a concept. So let's just say we have int. So first up here, let's just have int I1 equals 5, int I2 equals 9, and then system.out.println I1. So the first question is, are we allowed to do system.out.println I1? Well, yes. Now, the second question is basically, are we allowed to do system.out.println I2? Well, the answer is yes. Third question is, are we allowed to do system.out.println I1 outside of this block? Yes, because I1 was defined outside of this block. Now, next question, if we do I1 equals 2 inside of this block, will I1 be changed? Well, the answer is yes. Changes apply. It's just that variables declared disappear. Now, finally, are we allowed to do system.out.println I2? No, because I2 was defined inside of the block. And similarly, are we allowed to do I2 equals 4? No, because I2 disappears. On the other hand, are we allowed to do string I1 equals ABC? No, because I1 is already defined. Are we allowed to do string I2 equals ABC, however? Well, yes, because actually I2, it disappears outside of this block, so therefore we can use it again. Another example for int I equals 0, I is less than 5, I plus plus. We have a variable here. However, it's defined inside of this for block, so therefore it cannot be used outside of the for block. That won't work. Similarly, I can be reused. Now, what if we have the following? Int I equals 0. Note that we are allowed to do this because I here disappears outside of this for block. Now, for semicolon, I is less than 5, I plus plus. Now, what will happen if we print I? Well, actually, it'll be 5 because I will be modified by this loop inside here. Because changes made to a variable inside a block still count. It's just that variables that originate from the block don't count outside the block. Now, what about this? So let's just say we declare a variable, let's just call it II. Are we allowed to print it? No, we're not allowed to print it because it may not have been initialized. In Java, such a value is called a garbage value. You don't want that. Now, what if we do II equals 7? Then are we allowed to? The answer is yes. Now, let's do II equals 7 inside this block. And just to make it more applicable, pretend it's an if true block. Okay? Or if something and that thing is true. Then will we be allowed to print it? Well, it turns out actually, yes. Well, if we change this thing, however, to something else, like boolean b equals true, if b, then II equals 7, then we have problems. So, why do we have problems in this case? It's because we did not initialize the variable here, so Java does not know whether this code is executed. So therefore, if b is somehow false, then I would not be initialized, which is not good. Of course, we know that B is true, but Java doesn't know that. Now, of course, there's a special case made when this is an if true, because Java knows for sure. But if we just have something like this, we can't. So therefore, when we declare a variable inside of a method, we should usually initialize it, just to prevent stuff like this from happening. Now, let's take a look at variables in other methods then. So, first of all, let's just have our most basic method right here so far. Now, we used our variable a before in the main method, right? So let's use it again here. Is that allowed? Yes. Why is that allowed? Well, it's because we have int a equals 5 is declared inside the main method block. And remember, anything inside brackets is actually a block. So then therefore, since a is defined inside the main method, it disappears outside the main method. So therefore, we're allowed to use it outside of the main method. And now, what about II? Same reason. We're allowed to use int II equals 7, for example. That's allowed. Because II disappears outside the main method. Similarly, if we define a variable named xx equals 0, well, we cannot access xx here. That won't work. However, we can redefine xx. And in fact, we can even redefine it to a different type. And that's only because xx is defined inside x, so therefore it runs out of scope outside of this method. Now, this raises the question, what if we want variables that every single method in this class can access? That is where static variables come to use. So public static int, let's just call this global, equals 9. So this variable is accessible to every single method. So therefore, we can do system.out.println global, and it'll work. 9. Let's say inside of our x method, we do global equals 11. Then we call our x method, and then we do system.out.println global. We have that global is now 11 because x successfully modified it. Are we allowed to print global inside of x? Yes. Basically every single method can access a static variable, or at least every single method in this class. And it doesn't matter where I declare this variable. So public static string global 2 equals ABC. I can still access it even in the main method. Because the order of methods does not matter. Another thing about static variables is that you do not have to initialize them. Int, let's just say global 3. In Java, if you declare a variable without initializing it in a method, then you cannot print it. You have to first initialize it. However, if you do it in as a static variable, then you're allowed to access it. And in this case, it'll be the default value, 0. Just similar to how in arrays, if you don't initialize their values, they go to their default value. Now, of course, you need to be careful with that. For example, public static string global 4. Now, if we do system.out.println global 4, it'll be null. which you don't want to mess with, because now if we try global for.length, it's not a compiler error because it's allowed, but then it's going to be a runtime error. So that's not good. And another thing is, let's just say we have public static int g5 equals 7. Now, we're allowed to do stuff like public static int g6 equals g5 plus 6, for example, like that. However, we're not allowed to do stuff like public static int g7 equals g5 before g5 is declared. That's not allowed. So, in general, the order of static variables matters, but it doesn't matter where you put methods. No matter where you put methods, all these variables are going to be visible, because Java always executes the variables, lines of code with variables first. And of course, you're directly inside of this class block and you're outside of a method, you're not inside any other block, then the only thing you can do are declare variables. So you're not allowed to do stuff like g5 equals 9. That is not allowed because that's outside of a method.